Hello guys, I am from Gaugrass Math Sub. I am going to discuss some concepts related to chapter 4 determinant of NCERT 12 mathematics. First of all, I shall discuss about properties of determinant. Number 1. R1 interchange to C1, comma R2 interchange to C2, comma R3 interchange to C3. Then the value of determinant does not change. Let determinant be of order 3 cross 3. Let the determinant be of order 3 cross 3. Let the determinant be of order 3 cross 3. Then R1 interchange to C1 means first row is interchanged to first column. R2 interchange to C2 means second row is interchanged to second column, and R3 interchange to C3 means third row is interchanged to third column. Then the value of determinant does not change. This is the first property. R1 interchange to C2, C1, R2 interchange to C2, R3 interchange to C3. In this case, the value of determinant does not change. Second property I am going to discuss here. Second property is R1 interchange to R2. R1 means first row, R2 means second row. First row is interchanged to second row. In this case, R1 interchange to R2 or C1 interchange to C2. R1 interchange to R2, first row is interchange to second row, or first column is interchange to second column. Then the sign of determinant changes. First row is interchanged to second row, or first column is interchanged to second column. Then the sign of determinant changes. Now I shall discuss third property. Third property, if any two rows are columns are identical, if any two rows or any two columns are identical, then the value of determinant comes out to be zero. Any two rows or any two columns are identical, then the value of determinant comes out to be zero. Let determinant A equal to date 1 1 1 1 1 1 3 4 5. This is determinant of order 3 cross 3. In this case, first column has the elements 1 1 1. Second column has the element 1 1 1. Since first column C1 is identical to second column C2, C1 is identical to C2, then value of determinant comes out to be 0. If any two rows or any two columns are identical, then the value of determinant comes out to be 0. So here first column and second column are identical. That's why the value of determinant will be 0. Third property I am going to discuss here. Fourth property. If determinant has order n cross n, and a scalar small k is multiplied to date A, then we have the formula. Here scalar k is multiplied to date A. What will happen? Equal to k is a scalar. Here date A, here I have let date A equal to, right here element of first row 1 1 3, elements of second row 1 1 4, elements of third row 1 1 5. Then here a scalar k is multiplied to date A. In this case, this k will multiply to only any one row or only any one column. So here I can write very well. K is multiplied to first row. So it will become 1k. Right here 1k. Here write 1k. Here write 3k. Here write 1 1 4. Here write 1 1 5. This will be equal to, here write 1k, here write 1k, here write 1k. Comes out to be 1, 3, 1, 4, 1, 5. This is a third property. If data has the order n cross n, a scalar k is multiplied to date a. So here scalar k is multiplied to date a, or this determinant has the order 3 cross 3. This result we will have. Fifth property I am going to discuss here. If date has order n cross n, then date Ka, date K comes out to be k raised to the power n dot date A. If the date has the order n cross n, then date Ka, here k is a scalar multiplied to determinant A, then it will become k raised to the power n dot date A. Sixth property I am going to discuss here. Sixth property will be R1 goes to R1 plus k times of R3. R1 goes to R1 plus k times of R3. Here k is a scalar. In this case, the value of determinant remains unchanged, comma, C3 goes to C3 minus 4 times C1. Here you can see R1 goes to R1, 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 C3, C3 must be there. Then you can add or subtract of any scalar times of any row or any rows. Here rows are available, so here rows, rows, rows. Here column, column, column must be there. In this case, yeah, again I can write here R3 goes to R3 minus R1 minus R2. R3 goes to R3 minus R1 minus R2. In this case, the value of determinant remains unchanged. Then the value of determinant remains unchanged. This is sixth property I have discussed here. Seventh property I shall take here. Let date A is equal to 1 plus A, 2 plus B. First column I am going to write here. 3 plus C. Here you can write P, Q, R, M, N, L. In this case, I can write very well. This will be equal to, here you can see in first column, two things are added, 1 plus A, 2 plus B, 3 plus C. So what we'll do in this case, here I can write 1 P M, 2 Q N, 3 R L, added to A P M, B Q N, C R L. This can be related. Here you can see PM, PM, QN, QN, RL, RL, PM, QN, RL. But here 1 plus A can be written as here 1 plus A. 2 plus B can be written here 2 plus B. 3 plus C can be written as 3 plus C. Here I have discussed first property, second property, third property, fourth property, fifth property, sixth property, seventh properties. First property I have explained here. Let the determinant be of order 3 cross 3. Then R1 interchange to C1, R2 interchange to C2, R3 interchange to C3. Then the value of determinant does not change. Second property I have mentioned here, R1 interchange to R2 or C1 interchange to C2, then the sign of determinant changes. Third property I have mentioned here, if any two rows or columns are identical, then the value of determinant comes out to be 0. Let date A is equal to date, two columns 1 1 1 1 1 1. Here first column has the element 1 1 1. Second column has also the element 1 1 1. In this case, here C1 is identical to C2, then the value of determinant comes out to be 0. Fourth property I have mentioned here, if date has the order 3 cross 3 and a scalar k is multiplied to determinant A, then k times of determinant A is equal to k dot date elements of first row 113, elements of second row 114, elements of third row 115 equal to, here k will multiply to first row. First row elements of first row 1k, 1k, 3k. Elements of second row 114, elements of third row 115. This will be equal to, here the scalar k is multiplied to only one row, first row. Here in this case, the scalar k, the same scalar k is multiplied to first column. First the element of first columns are 1k, 1k, 1k. And second column, third column remain the same. Fifth property I have mentioned here, if the determinant has the order n cross n, then date k times of A, date comes out to be k raised to power n dot date A. Here this property can be explained. Suppose here k element k multiply to, here the elements of first row is 1k, 2k, 3k. Also here if you find 5k, 6k, 7k, 8k, 9k, 10k. In this case, you can take k as a column, as a common. You can take k as a common from first two. So comes out to be k. Again, you can take k as a common from second row. So you will get here k. Also, you can take k as a common from third row. So you get here k. Multiply to 1, 2, 3, 5, 6, 7, 8, 9, 10. You will get here k raised power 3 dot this determinant. This is the explanation. Sixth property I have mentioned here, R1 go to R1 plus k times of R3, comma, C3 go to C3 minus 4 times of C1. Here this is C1. R3 goes to R3 minus R1 minus R2. Then the value of determinant remains unchanged. And seventh property I have mentioned here, date A equal to date elements of first row 1 plus A PM. Elements of second row 2 plus B QN. Elements of third row 3 plus C RL equal to, here 1 plus A, 2 plus B, 3 plus C can be expanded. Further, this plus will be added here, plus, and here 1, 2, 3 represented here 1, 2, 3, and ABC will be represented here ABC, and this plus will be reflected at this place. So here I have mentioned 7 properties related to determinant belong to chapter 4 of NCERT 12 mathematics. Okay, thanks.